Hello friends, in my last video I discussed the things, in fact I tagged it everything you need to know about a circle. Today we are still talking about part of a circle, and this question came out in Waec 1992. This is a Waec past question 1992, and look at the question how it is. So they said the diagram below shows the shaded segment of a circle of radius 7 cm. If the area of the triangle OXY is 12 fold number 1 over 4 cm squared, calculate the area of the segment. Look at the segment here, and in that last video I told you that area of segment equals the area of the whole sector, area of sector minus area of a triangle. Okay, so when you remove the area, if I cut off this area of the triangle from the whole sector, what is left is the segment. And the area of the triangle is known. They have given us the area of the triangle. So the only problem we have here is the area of the sector. And the area of sector is given by the formula theta over 360. This A means area of sector, times pi r squared. This will give you theta is the angle here, which is 30 over 360 times pi is 22 over 7 times the radius of the circle. Question says that the radius is 7 cm. So have 7 squared means 7 times 7, 7 squared. This 7 will cancel out this 7. 0 will cancel 0. 3 here is 1. 3 here will give us 12. Okay, now 2 here is 6 and 2 here is 11. So we are having 11 times 7 is 77 all over 6. So this is our area of sector. Okay, now let's change this area of triangle into improper fraction. So area of the triangle is 4 times 12 is 48 plus 1, we have 49 all over 4. Therefore, the area of the segment we are looking for will now be area of sector, and the area of sector is now 77 over 6. So it's now 77 all over 6 minus area of triangle, which is now 49 over 4. 49 all over 4. So we can find their LCM. The LCM of 6 and 4 should be 12. 6 divided 12 is 2. 2 times 77 should be 154 minus this divided this is 3. 3 times 49 should be 147. And when we subtract, we shall get 7 all over 12. So this is the area of the segment we are talking about. So the area of this segment is 7 over 12 cm squared. If I like, I can still put it into a decimal, but let's leave it as a fraction since we don't have calculator. Let's take one more question on this. Right, let us solve the last question. This is Waec 1992 number 8A question from the theory, and we are told that we should calculate the area of the shaded segment of the circle shown in the diagram below. You can see the diagram here, and the shaded segment has a formula for each calculation. So you should know that area of segment is the same thing as area of sector minus area of a triangle. Okay, so the required area of segment will now be area of sector is theta over 360 times pi r squared minus area of triangle is half r squared sine theta. This is just the formula which I use to solve that. This is now equal to my theta is 63 degrees, so I'll have 63 over 360 times pi is 22 over 7 times my radius is 10, so I have 10 all squared. This is for sector minus area of triangle is half times radius is 10, so I have 10 squared sine the angle is 63 degrees. This will now be, I have to multiply the numerator separately before I go into the denominator. So here 63 times 22 times 100. You know why I said 100? 10 squared is 100. So this will give us 138,600 over 360 times 7 is 2520. Okay, minus, coming here, 10 squared is 100 and half of 100 is 50 times sine 63. So let's find sine 63. Sine 63 is 0.8910. So we'll finalize by dividing this by this. When I say 138,600 divided by 2520, this will give us just 55, minus, you multiply 50 by the decimal, so have 50 times 0.8910. This will give us 44.55. Okay, now we subtract. When we subtract, the answer is giving us 10.45 centimeter squared. So this is the required area of segment. So the area of segment is 10.45 centimeter squared. So if you've enjoyed what you've watched, kindly share, like, and most importantly, subscribe to my channel and turn on the bell notification icon so that it will notify you whenever I upload a new content. Thank you.